All right, guys, so to find terminal speed, if I wanted to come up with an expression to calculate terminal speed, we know then that that's when the resistive force is going to be equivalent to the weight force in this case. So when that happens, acceleration is going to be 0 because we'd have 0 net force. And we just found an expression for acceleration. And that was acceleration is equal to g minus bv over m. V, in this case, is going to be terminal speed. So I want to designate that this is going to be V, and then we'll do a subscript T to represent that this is talking about terminal speed. So when this is equal to 0, when A is equal to 0, I want to come up with an expression then for VT, for our terminal speed. If I rearrange this equation, I would get terminal speed is going to equal mg over b. So this is going to be my expression or calculation to find terminal speed in terms of mg and b. Now, let's say that we want to know about a speed before we've ever reached terminal speed. How would we do that? Using lots of differential equations, we could find a formula to find a speed at any time during the motion with this resistive force. We're not going to derive this one. Instead, this one's going to be given to you. So in this case, if we're solving for using some differential calculus, we're going to end up getting a formula where we could find the speed of a mass that is on its way to approaching that terminal speed, and that could be at any time. So if I'm thinking about that formula will be V equals Vt times 1 minus e to the negative time over the Greek symbol tau. Now, tau is representing a time constant, and that time constant is just the time at which something is released from rest, and then it reaches a certain amount of its terminal speed. So our time constant we can find by using the equation tau equals m over b. So we can calculate tau. We can always calculate our time constant. And t, time, is just going to represent the time it's going to take for that to get to that speed. So, let's go back to that equation really quick, guys. Sorry, I didn't finish those parentheses. So to find a speed at any time during the process of this mass moving through a resistive force or moving through a specific medium is going to be equal to terminal speed times 1 minus e to the negative t over tau, where tau is just representing a time constant. And I think we're going to have a sample problem with this. So let's say that we have a small sphere of mass 2 grams is released from rest in a large vessel that's filled with oil, where it's going to experience a resistive force that's proportional to its speed. The sphere reaches a terminal speed of 5 centimeters per second. Let's determine the time constant, and let's determine the time at which the sphere reaches 90% of its terminal speed. Okay, so let's talk about the things that we know. We know mass. So let's just set this problem up. I know mass is equal to 2 grams. What else do we know? So mass is 2 grams. We know that the terminal speed is 5 centimeters per second. So let's write that down as well. I know Vt equals 5 centimeters per second. Well, then that means I also know acceleration due to gravity, which would be, if this is going to stay in centimeters per second, I need to convert then my acceleration due to gravity in centimeters per second. So that would be 980 centimeters per second. Okay, so I have mass, I have terminal speed, I have acceleration. We also know that we're going to have to figure out, or we want to know the time that it's going to take for the speed to reach 90% of its terminal speed. So I know that another speed that we're going to have to use probably is going to be when we're at 90% of our terminal speed. So I'm trying to find the time at which I have a speed that is equivalent to 90% of that terminal speed. So I can also write that expression up there as well. Okay, first step, they want us to find the time constant. I need to find tau. And I know that tau can be found by finding mass over B. Okay, well, I don't know B. They didn't give me a number here for B. So I know that there's a relationship between terminal speed and B, because we also know an equation that says terminal speed is equal to mg over B. Well, I know mass, I know acceleration due to gravity, I know terminal speed. So if I rearrange this equation to equal B, so B equals something, I could plug that in for B here and find tau. Let's do that. So if I rearrange this for B, I would end up getting B equals mg over Vt. Well, now let's take that and substitute that in here for B. So now I would get tau equals mass, and since this is on the denominator, let's just multiply this in by the reciprocal, because that would be the exact same thing. So mass times Vt over mg, then that means masses would cancel. So tau is just going to equal that terminal speed over g. Well, do I have those things? I do. I know terminal speed is 5 centimeters per second, and I know acceleration due to gravity would be 980 centimeters per second. So then if I took my 5 divided by that 980, then that should give me 5.10 times 10 to the negative third. And that would be, oh, sorry guys, that should be seconds squared. And that would be seconds. So we should get our tau to be 5.10 times 10 to the negative third seconds. So let's write that up here. Let's write it with the rest of our variables since we know it now. So tau is 5.10 times 10 to the negative third seconds. Okay, so we've answered the first part of this problem, so we're halfway done. The next part of the problem is asking us to find time. And I know that time and tau and terminal velocity are all related by this equation. V equals Vt times 1 minus e to the negative t over tau. So we know this. I know that V is when it's about 90%, or when it's 90% of that terminal, 90% of that terminal speed. So I could say, I could plug that in here. Let's do that. 0.900 Vt equals Vt times 1 minus e to the negative t over tau. So I could start setting it up this way. If I'm looking then at this, I could cancel some things out here, right?